Hey guys, in this video I'm going to show you how to connect an LCD to the Raspberry Pi, and then I'll show you how to program it with Python. I'll show you how to do basic stuff like positioning text, turning on and off the cursor, and printing the date, time, and IP address. Then I'll go into more advanced stuff like scrolling, creating custom characters, and printing data from a sensor. Alright, let's get started by connecting the LCD to the Pi. I've got my Pi with the breadboard here. First thing I'm going to do is insert my LCD into the breadboard. Then I'll insert a 10K ohm potentiometer for contrast control, and another 10K ohm potentiometer for the backlight brightness. Now I'll connect the VSS pin of the LCD over to the negative rail of the breadboard. Then I'll connect the VDD pin of the LCD to the positive rail of the breadboard. Now I'll connect a jumper wire from the VO pin of the LCD to the center pin of the contrast potentiometer. Then I'll connect the RS pin of the LCD over to pin 37 on the Pi. Now all the pin numbers I'm talking about here will refer to the pin numbers on the board. Next I'll connect the RW pin of the LCD over to the negative rail of the breadboard. Then the E pin of the LCD over to pin 35 of the Raspberry Pi. I'm going to show you how to connect the LCD in 8-bit mode first, then I'll show you how to connect it in 4-bit mode. I'm going to use a 4-wire ribbon cable and insert it into the breadboard at the LCD data pins D0 to D3. Then I'll connect it to the Pi with LCD pin D0 connecting to pin 40 of the Pi, LCD pin D1 connecting to pin 38 of the Pi, LCD pin D2 connecting to pin 36 of the Pi, and LCD pin D3 connecting to pin 32 of the Pi. Now I'll use another 4-wire ribbon cable to connect data pin D4 of the LCD to pin 33 of the Pi, LCD pin D5 to pin 31 of the Pi, LCD pin D6 to pin 29 of the Pi, and LCD pin D7 to pin 23 of the Pi. Now I'm going to connect a jumper wire from the A pin of the LCD to the center pin of the backlight brightness potentiometer. Now I'll take another jumper wire and connect the K pin of the LCD to the negative rail of the breadboard. Next I'll take a jumper wire and connect one side of the contrast potentiometer to the negative rail of the breadboard. It doesn't matter which side. The side you connect will only affect which direction knob turns increase or decrease the backlight brightness. Next I'll connect one of the outer pins of the backlight brightness potentiometer to the positive rail of the breadboard. Same thing here, the side doesn't matter, it's just going to determine if clockwise or counterclockwise turns of the knob turn up or down the contrast. Now I'll connect the positive rail of the breadboard to the 5-volt pin of the Raspberry Pi, pin 2. Then I'll connect the negative rail of the breadboard to the ground pin of the Pi, pin 6. Okay, so that's how to connect it in 8-bit mode. Lots of wires, right? Well, we can get rid of 4 of these if we use 4-bit mode. We just remove the wires connecting LCD data pins D0 to D3. Now let's get into the programming and see what we can do with this LCD in Python. I'm assuming you've already established an SSH connection or some other way to access the command prompt. I'll be using PuTTY here, so let me just log into my Pi real quick. I'll be using a library called RPLCD to help with the programming. This is the best Python LCD library I've found so far. We can download the RPLCD library from the Python package index, or pip. Pip may already be installed in your Pi, but if not, enter sudo apt-get install python-pip to install it. Now to install the library, enter sudo pip install rplcd. Now we'll want to reboot. You'll probably want to check out this blog post. I'll leave a link to it in the description. But here I've got all the wiring diagrams and example code I'll be using. You can just copy the example programs instead of typing them in manually. Here's the 8-bit mode wiring diagram, 4-bit mode diagram, how to install the library. There's a Hello World example for 8-bit mode if you're interested. Let's start with a simple Hello World program so you can see what's necessary to initialize the display and print a simple text string. This is the LCD initialization function. This is where you can set the column width of your LCD, the number of rows, and set the pins for connecting the LCD to the Pi. The nice thing about the RPLCD library is that it uses the pin numbers on the board of the Pi. You can set the pins for the LCD's RS pin, the E pin, and the data pins. The data pin numbers here are in order, starting with LCD data pins D4, then D5, D6, and D7. And to actually print text to the screen, we use the function lcd.write_string. So let's copy this. And we're working in Python here, so I'm going to create a file with a .py extension, lcd.py. Then I'll just right-click to paste that code in here. Control-X to save and exit. Now to run the program, I just need to enter sudo python lcd.py. There you go. Hello World is printed to the screen. So by default, text is printed to the display at the top row, first column. But you can place your text anywhere on the screen with the LCD cursor position function. The numbers inside the parentheses here are the row number and column number where the text should be placed. The rows are numbered starting at 0, so the top row is 0 and the bottom row is 1. The columns are numbered starting at 0 as well. So in this program, Hello World will be printed to the bottom row, fourth column. Here's a little trick. Instead of retyping commands you've already entered, you can use your up and down arrow keys to scroll through your history of previous commands. So I'll open up my lcd.py file, Control-K to cut this old code out, and right-click to paste the new code in there. There you go. Hello World is printed to the bottom row, fourth column. To clear text from the screen, use the LCD clear function. This program writes Hello World to the LCD, sleeps for 2 seconds, then clears the screen. There's Hello World. Now it's been cleared. I'll run the program one more time. We can create a blinking text effect by using the LCD write string function and the LCD clear function in a while loop. This program will write hello world to the LCD, wait for 1 second, clear the screen, wait another second, and then loop back to the beginning. If you have a lot of text or data to display, this is one way you could do it. You don't have to blink the same text string on and off. You could use this to print multiple sensor readings, metadata for a song, or other information that doesn't fit on the display. Press Ctrl-C to exit the program. The RPLCD library provides functions for controlling the cursor too. You can have a blinking block style cursor or a non-blinking underline cursor with these functions right here. Let's see the blinking block style cursor. The cursor is placed after the last character in the text string. Now let's see the underline cursor. I'll just comment out this line, and then uncomment this line. Okay. And cursor mode hide turns off the cursor. If you have a text string that's longer than the column length of your LCD, the text will automatically wrap down to the next line. But you can create a line break anywhere you want by inserting \n\r in the text where you want the break to occur. I have \n\r in between hello and world here. So this program will print hello to the top row and world to the bottom row. You can print the date and time to your LCD too. This program will print the time to the top row and the date to the bottom row. There we go. This program here will print the IP address of your Pi to the LCD. This is the IP address of my Ethernet connection. You can also print the IP address of your Wi-Fi connection by coming down here to line 19, and changing this ETH0 to WLAN 0. And here's the IP of my Wi-Fi connection. Each character of the LCD is a grid of 5 by 8 pixels. You can make any pattern within that grid and print it to the screen as a custom character. Up to 8 custom characters can be defined and stored in the LCD's memory at one time. I have a link to a website here that will help generate the code you need to define the custom characters. This is the part you need right here. I'll just copy this over to Nano. First, we define the custom character with the code from the character generator. This program will print a smiley face, so I name the character Smiley. Next, we use the LCD create_char function to store the smiley in the LCD's memory location 0 and include the name of the character. Then we print the character to the LCD using the LCD write string function with the term UNICHR in parentheses. The 0 in UNICHR refers to the LCD memory location where we chose to store the custom character we defined up here. Okay, let's see what this looks like on the LCD. Alright, so there's our smiley face character. As I mentioned earlier, up to 8 custom characters can be defined and stored in the LCD's memory at a time. Let me just copy this real quick and paste it into Nano. Using multiple custom characters is similar to using a single custom character. We give each character a different name and define it separately. The characters need to be defined in order here, from 0 at the top to 7 at the bottom. I'm going to define 5 different characters here: the Greek letters omega, pi, and mu, and a water drop symbol called drop, and a thermometer symbol called temp. Now we load the characters defined above in the LCD's memory with the LCD create char function. I defined the omega symbol first, so its memory location will be 0. Pi came second, so its location will be 1, and so on. Then we write the characters to the LCD using the LCD write string function for each character, with UNICHR and the memory location of each character in parentheses. So let's see what this looks like. Alright, there's our omega, pi, and mu symbols, plus a water drop symbol and a thermometer symbol. Okay, now let's see some examples for scrolling text across the screen. Scrolling is a good way to display text that's too long to fit on the screen. This program will scroll a string of text from right to left in an infinite loop. Let me just get rid of this. Paste that in there. You can change the scrolling speed too. Down here in the delay term on line 19, I'll change it to 0.1 seconds. So now the text scrolls at a rate of 0.1 seconds per character. Alright, now let's see how to print data from a sensor to the LCD. I'll be using the DS18B20 digital temperature sensor here, but this will work with any sensor. All you need to do is put the variable for your sensor reading in the LCD write string function. If you want to try this with the DS18B20, there is some setup to do before it'll work on the Pi, so check out our tutorial on that to see how. I'll leave a link to that post in the description instead of going over everything in this video. I'll set up the DS18B20 here real quick. I've inserted the sensor into the breadboard with the flat side facing me. I'll insert a 4.7 kilo ohm resistor between the center pin and the right side pin of the DS18B20. Then I'll connect the center pin of the DS18B20 to pin 7 of the Pi. Next, I'll connect the positive rail of the breadboard to the right side pin of the DS18B20. And connect the left side pin to the negative rail of the breadboard. Now I'll copy this, paste it in there, and here are the temperature readings with Celsius on the top row and Fahrenheit on the bottom row. Again, it's really simple to print sensor readings. All you have to do is put the variable that contains your sensor reading in the LCD writeString function, just like you would any other text string, but without the quotation marks. Alright, well that's about it. Thanks for watching. If you like this video, be sure to like it and subscribe to our channel. We've got lots more video tutorials coming out soon for the Raspberry Pi, and I think you'll find them really useful. Okay, talk to you next time. Bye-bye.